Hello everybody, this is Jeff Janess. Welcome to our 7th lab exercise on raster analysis. And in this exercise we're going to try out another of our general raster tools that we discussed in the first lecture video for this module, the Zonal Statistics as Table tool. And we'll see how to calculate descriptive statistics from raster cells within an analysis area polygon. Now we're also going to do it two ways. First with continuous data such as elevations, curvatures, slopes, and TPIs, and again with circular data from our aspect raster. It's pretty cool this tool will handle circular data. It's got the circular statistical functions written into it, so we're going to take advantage of that. Now in this lab exercise we're going to use our Semester D Management Unit polygon as our analysis zone so that statistics will be calculated using only those cells inside the polygon. Now, the concept of a zone is really important for this tool. It gives you the ability to calculate statistics using individual features or groups of features as the zones. You could even use a categorical raster to delineate zones. Now take a look at our first lecture video in this module for a discussion of how zones are defined and used by this tool. And that video also discusses a problem people often run into with this tool when they use overlapping polygons for their zones. Now in this demonstration I'm going to be using ArcGIS Pro version 3.3.2, so if you're using a different version the tool windows might look a little different. Also, the tools we'll be using are available in a few extensions in ArcGIS Pro. We're going to be using the Spatial Analyst extension, so let's start by making sure that license is turned on. We just pop over to the Project tab, come down to Licensing. Now scroll down in this list of licenses to find Spatial Analyst and see if it's turned on. So for me it is turned on, so I'm ready to go. But if you do not have it turned on, you'll have to hit your Configure Your Licensing options to turn that on before you do this. Okay, let's get started. First thing we want to do is add the Semester D Management Unit and the DEM. These are from our Raster Functions folder. So we come to Catalog, we go to our folders and our class GIS data in the raster functions. So we're going to load up the DEM and the Semester D unit. Right-click on them. Now I'm just going to add it to this map I've already created. I've called it Zonal Statistics Lab. It's sitting right up here. So I hit Add to Lab. It'll just pop both of those layers in there. Okay, there they are. Now we also have to add the various data sets we've created in the other lab exercises in this module. We did aspect, slope, 3 versions of curvature, and TPI. So those I have been storing in the database called, well, this database, and you should know where you've been putting them. So go to your geodatabase where you've been storing the stuff. I'm going to load aspect, mean curvature, plan curvature, profile curvature, slope, and TPI. Just right-click on them and say Add to the map. Okay, now we have all our data in here. And just for visual qualities, I'm going to turn all the layers off except for the DEM. Okay. Now the tool's pretty easy to run. Go to the Analysis tab, then Tools, search for Zonal Statistics as Table. And by the way, notice there is another tool called Zonal Statistics. That is not what we want. Do not accidentally click on this one. We want the one that's called Zonal Statistics as Table. And here it is. We're going to use the Spatial Analyst version. Okay. So we start by setting the input raster feature zone. This is the data set that will define the zone, and we're using this blue outline as our management unit. That is our zone. So we put that layer in here. We're going to use the zone field as the object ID. And again, take a look at that first lecture video to understand what this zone field is and what zones are. It's really important. Okay, we're going to start with the DEM. We're going to get the elevation statistics within here. Just drag DEM into the value raster. We're going to name this data set, statistical table DEM stats. We're going to leave the Ignore No Data in Calculations unchecked for now. This option means that if there were any null value cells inside our analysis area polygon, or if our polygon extended outside the extent of our rasters, the tool would not calculate any statistics at all for this polygon. It's a good option for us to have because it allows us to catch cases where there might not be enough data to generate good statistics for a region. But in this particular lab exercise, it really doesn't matter if we check the box or not because our polygon is entirely inside the extents of the rasters, so I'm just leaving it unchecked for now. Statistics type will be all. This means it gives us all the general statistics. We'll leave this percentile value as 90. It gives us the 90th percentile. It's just one more statistic. Percentile interpolation, we'll leave it as auto detect. Leave these unchecked, and we'll leave the output layer empty. So this is good to go. We just hit run. We open up. See, it's added a new table to our map down in a little section called Standalone Tables. So you open that up. And here we see we have the minimum elevation, the maximum elevation, the range, all the standard statistics. The count is the number of raster cells that were within the polygon, within the zone. The area is the number of cells multiplied by the area of each cell. So this will be in the square units of whatever the coordinate system the data set is. And our DEM is in meters, therefore the management unit is this many square meters in size. All right, so we've already done a good part of our lab, calculate all these statistics for elevation. Okay, so now we just repeat the process with our other continuous data sets. So let's drag in mean curvature in here. We'll just call this mean curvature stats. Hit run. We'll do all of these the same way. We'll do plan curvature next. Okay, profile curvature. You see, this is pretty easy to do. I'm going to do it with slope now, slope stats. Now regarding slope, remember from the lecture video number 2 in this module that if you're going to calculate statistics on slope, your slope had better have been originally generated in degrees. If these are percent values, then the statistics will be inaccurate. So take a look back at that video if that's confusing at all. We got slope. Now let's do TPI. And hit run. Okay. All right, so we now have all of these tables of statistics. They have the full set of descriptive statistics for each of these rasters that we've been generating over the course of this module. And you will just need to, for those of you who are in my NAU classes, you will just need to fill in this table with those values. So this is your homework right here. It's pretty easy like you saw in the DEM. You just open the table. And one nice thing about this, you don't actually have to try and type this. You just right-click on this and do copy. You can paste it into the document, so that'll be a little shortcut for you. And I'm not going to open these others because this is homework after all, so I don't want to just give all the answers away. All right, so now let's do this one more time, but with the aspect. So aspect is a circular variable. Remember that from lecture video 2 in this module. So we drag up aspect in here. We're going to call the output table aspect stats. And here we have to turn on calculate circular statistics. This will change how the algorithms work. It'll use circular statistics instead of linear statistics. And so it's pretty cool that we'll do it. Now, circular data means that the data starts at some value like 0 degrees. It increases to some maximum number like 360 degrees, and then it starts again at 0. So this is sort of preset for degrees around a circle, but it doesn't have to be. If we had some other cyclical data set, maybe we had some data set that was monthly or weekly or something like that, you could change this to 12 or 52. That'll say what what point at which it restarts at the 0 again. But since we're using aspect, we'll just go with 360 as the right one. We hit run. Okay, so now we have a new table of aspect stats. Now, this has a different set of fields in it because there are different statistics available in the circular statistical function. So we just hit open on this. We see that it has the count and the area like it did before, but now it has C mean. This means a circular mean. This is the mean direction. Take a look back at that second video again to see what I mean by this. This is the circular standard deviation. So variation in direction, the mean direction. This is actually fairly high value for a circular standard deviation. That means that there is a lot of variation in the directions. And this just means that our management area doesn't seem to face any particular direction. All right, and that's all there is to it. Thanks so much for taking part in this. In our next lab exercise, we're going to see how to extract raster values at point locations. It's something we do quite often. Maybe we have a bunch of point locations. It could be from a GPS or radio telemetry. We want to know what the elevation, the slope, or the TPI values were at each point. Our next exercise will show you how to do that, and also explain the differences between interpolated values and exact values. Hope to see you there. In the meantime, y'all take care. Thanks again for listening, and we'll see you next time. Bye-bye.